Hi guys, I'm just going to quickly cover more rate graphs, but this time it's concentration versus time. So if we look at the zeroth order, so zero order, where the concentration of A, for example, doesn't matter, then we see rate is equal to K. And as we can see here, when time progresses through the reaction, so this is just time, like a length of, let's say, an hour, if the reaction progresses, concentration will decrease at a linear rate. Because it's being used, but it doesn't depend on the rate. Because just because concentration is equal to 0 doesn't mean it's not used. It's still used, but it doesn't affect the rate whatsoever. And so as we can see, concentration will go down over time, but the rate is equal to this. So basically, you're looking at the rate here. The rate will continually remain the same until the concentration is 0. Because as you can see, rate is independent of this. So it doesn't matter how much we start with, how much we have no matter what. Like if this is suddenly half the value, the rate will still be the same throughout the whole thing because it's completely independent. First order, first should help you realise where the dependency comes from. As you can see here, it's a slope which isn't linear. This is because rate is dependent on the concentration of A. As time goes on, the concentration will always decrease. That's just a standard of at least a reactant. And so as time goes on, concentration of A will slowly start to fall. And rate is dependent on K, which doesn't change, and A, which is changing, it's now decreasing. If you imagine this is just some number, it's going to get smaller if one of these becomes smaller as well. And so as you can see, it gets smaller and smaller and smaller. Second order, however, this is squared, so rate is more dependent on A here. So if A gets smaller, then rate is going to exponentially get smaller. And so this drop off here is suddenly huge compared to this. If I was to grab a ruler and show you time for both of these reactions, you can see that the drop off for second is there, but the drop off for first is up here. So you can see that in the second order reaction, the drop-off is much faster than in the first. This is because rate is more dependent on A. But in O, obviously it will be up here because it just doesn't matter, it's linear. Hopefully that helps.